Hello and welcome back everyone. Today I'll be showing you how to make a very simple collision detection tutorial. Giving you a very simple collision detection tutorial in Scratch. So quick rant, I'll leave a link in the description so you can skip ahead to actually get to the tutorial. But anyway, quick rant. When it comes to collision detection, the general way you do it is you walk into a wall, right? So you're allowed to move freely left and right and obviously up and down as well, but left and right, just as an example. So you move right, but then you end up walking into a wall, and that obviously causes problems due to the fact that you're inside of a wall. So very simply, move into a wall, push you out the other way. Simple enough. But that can often lead to quite glitchy looking effect, where you're one frame you're in the wall, the next frame you're out, and it's sort of vibrating back and forth whenever you come in contact with the surface. And that can be especially bad if it's the same vertically, because then you're literally always vibrating, glitching, and that just doesn't look great. So instead you want to make a cleaner look, but like this, where you walk into a wall and you get flush against the wall, like that. So start with making a new project, right? Make a new Scratch project. Okay. I'll use this as a sort of guide myself. Well, anyway, so to start off just making a simple sprite. You can use the Scratch Cat if you want, but it's got a pretty rough edge around it, and that can cause some slight issues. So if you are going to use a Scratch Cat, I'd recommend just putting like a sort of transparent border around it. So probably a white border, and just draw. Oh, sorry. Just draw that around like that. Right, and then just put it backwards, so you end up with the cat in front of the square. So you don't see the square, but obviously it's still there. If you are going to use, obviously you can just make a your own costume if you want. And that's what I'm going to do. So it doesn't have to be anything extravagant, just a little. Preferably either just like a square or something. You don't want many like concave shapes like this, where you've got like like sort of concave angle here, because that can cause mild problems. Just if you get like caught like with that sort of section, you got like the platform here, and you're sort of caught like this. So it's best to just do like either a single square or a circle, which is what I'm going to do now. So just draw this square like that, and it doesn't have to be crazy. We'll just do like something like this. Down there. Looks good. Something like this. So you can turn it however you like. I think that's quite nice. Also, borders are annoying. Outlines, I mean. Damn it. Okay, let's get rid of the outline. It's got a simple square, right? You can make that look however you like. Anyway, so you want to start just drawing an actual background, for it to collide with. You can't have collision if you don't have anything else in the map. So just again, something very simple, just like it's best to try and have it all the same colour. Obviously, you don't have to, but to start with, just to get it to work. Because if you have like multiple sprites, it's easier to just say, to text, if you're touching something, if you're touching the colour black or colour red or whatever colour it is, rather than having to text each individual sprite, because that can it's just quicker, quite frankly. So a few simple shapes. So on a floor, probably a wall like this, maybe a lowish ceiling to test the ceilings. And you also want to have a sort of slope, which is what I'd recommend if you're ever going to make a test for collision. Just make sure you have these main elements like this, because these are all pretty important things for it to work with, right? And it works for these sort of elements. It's probably going to work for most elements. And if you really want to go crazy, you could just draw a sort of weird squiggly shape as well. Like that. Just to really test that it works fine, because it doesn't start like clipping near the corners or anything like that. But go to that, that's quite ugly anyway. Come on. Let me get rid of that. Anyway, so now I've got an actual level, if you want to call it that. We'll start with the collision detection. Obviously, start one green flag. Simple go to. Oh, sorry, stage lights. So green flag clicked. Start with simple, basically just go to the coordinates. Now lots of people try and do like when left arrow key pressed go left, when right arrow key pressed, but that can cause some problems, and you can see why. If I do when right arrow key pressed, change X by 5, rather than moving smoothly, it sort of has a little delay at the beginning and then it starts going. It sort of stutters a bit. So a way to get around that is just to, instead of having when right arrow key pressed, you have a forever if key right arrow pressed. So that way, as soon as you press right, just click moving back. As soon as you press right, it starts moving at a constant speed. There's not like a delay beforehand. And obviously you can duplicate that to if. Actually, instead of having to duplicate it to if left arrow key pressed, simple trick you can do is have change X by right arrow key pressed minus left arrow key pressed. And this might seem a bit counterintuitive, right? Because what on earth does this mean? But effectively, these are Boolean inputs, so 1s and 0s. So if neither of them are pressed, it'll be change X by 0 minus 0, which is staying still. If the right arrow key is pressed, it's change X by 1 minus 0, so change X by 1. And if the left arrow key is pressed, then it's change X by 0 minus 1, which would therefore move you in a negative X, which is the left. But obviously that's quite slow because you're only moving 1 pixel every frame. So just times this by however fast you want your character to move. I'll go with 5, I think that seems pretty nice. And you can just get basic movement in, right? And you can obviously do the same vertically. I'll just quickly do that again. Right, so up and down. So now you've got a character that moves around in 3D or 2D space, sorry. But here's where the collision comes in. The collision's actually pretty simple. What we do is before the change X by 5, we're going to make 2 new blocks actually. Collision detection. Copy this. Horizontal. And run without screen refresh. And then collision detection vertical. Sorry. Vertical. And again run without screen refresh. So we change the X by 5, and after changing the X, we check for horizontal collision detection, which define that as if touching color black, then repeat until not touching color black. And then we want to change the speed bit. I'll make again two new variables now. So speed x and just speed y. And now what we're going to do is we're going to actually swap something around. So set speed x and set speed y, and then we're just going to do this and this, and then change y by speed x and speed y. Right. If ever it starts lagging heavily, just know that because you've set run without screen refresh, it can cause quite a lot of lag if it repeatedly runs. So I'd recommend before actually, if ever you suddenly get a massive lag spike, then just like either press the red hexagon, red stop sign, or just remove the collision detection code, and you can fix whatever you need to fix. So now everything should work fine. Not fine, but better now. So now what we can do is we can just do change x. Sorry, not that. Change x by speed x times -1. What that does, so moving toward it moves in the opposite direction, right? Like that. Great. Although you may have noticed it can be a bit glitchy before we implement the y values, but that's just because we haven't implemented the y. So it can move downwards and then it will only detect horizontal movement, so it causes big glitches. But anyway, if we now do the same thing in the vertical direction, so after that we do collision detection vertical, and again we can define that very similarly, just obviously reverse. Right, so define collision detection vertical. If then just change the y by speed y times -1, and now this should work in theory. So what's the problem? Life coding. Find the problems and make a solution. Oh, sorry. Yes, that's that. Change x by speed x, speed y. Sorry. So now it should work just fine. As you can see, it does. It can get a little bit glitchy near slopes like this, however. And that's because we've set it so they can only move in increments of 5, right? So, it's basically, instead of having a slope here, it's basically like steps, each one 5 pixels big, and that obviously makes that sort of bouncy effect. So instead of just changing y by speed y times -1, what we'll do, I want to switch some things around here. So this should be the same, the speed's the same, but we've set speed y and speed x to be either -1 or 1, whatever. And we've just multiplied the speed y and speed x by a value, right? So you have something like this. So set speed x to key right, I pressed minus left arrow, pressed change x by 5 times the speed x, and obviously equivalent on the vertical, on the y axis. Anyway, alright, so now this creates a much smoother look, where the speed y and speed x are only, at most 1 or -1. So now slide much more smoothly down slopes like this, right? But it still is a bit weird, right? If you touch a slope like this, you still get stuck. And even if this is like, go into the back shop here. Even if this is like a very, very thin slope, right? I'm sorry. This, right? Let's take this, drag down. The player will still get stuck on it here if you move left and right. And obviously that is to be expected, but it is a bit annoying because obviously it means that, you know, it can be quite irritating when you're actually playing, getting stuck on the tiniest little things. So what I want to do is put a bit of leeway in, right? So what I'm going to do, we only really need to do this on the X coordinate because when it comes to the Y, you naturally move up and down in the Y position quite a lot just because of gravity when we do implement that. So what I'm just going to do is check for leeway. So you spell it? Yeah, okay. Anyway, check for leeway. And we'll just run without screen refresh. So, collision texture horizontal. If touching color black, then check for leeway. And try and check for leeway. What I'm going to do, actually I'm going to put another one here. If black. So, here what I'm going to do is I'm going to change Y. We're going to do a repeat, right? Repeat times 4. Depends how much leeway you want to give when it comes to like slopes like this. If you want to be able to climb really steep slopes, then set the repeat value to higher. I'm going to say 4. It's quite a, you know, so it goes, so it can jump up like 4 pixels at a time. It can be a pretty steep slope, but I think it should be fine for the purpose of this video. So repeat times 4. Change Y by 1, right? So when you come onto anything, it just climbs up like that a little bit, right? And this looks like it's all good, right? It can be a bit glitchy, but we can iron those glitches out later. But there's a problem. If you come in contact with a non-slope like this, it will still slide you up. So what we need to do is have this leeway check in place, but if it's still touching a black surface, right? Because here it jumps up and it's no longer touching black, as you can see here. Right? So that's good. There's clearly a slope there, or at least a very, very small bump that we wanted to be able to naturally walk over. So that's what we want leeway to do. If we do here and it's still touching black like it is now, even though it's checked for leeway, then we want it to reverse that check for leeway, right? So if it's still touching the colour black, then we're just going to change Y by -4, like that. So now, if it comes in contact with a wall that it can't climb up, then it's fine. But if it's a very shallow slope like this, it can still go up like that. But as you can see, it's still sort of hopping its way along, right, which is a bit annoying. So what we'll instead do, and instead of just having repeat times 4, that's why I didn't just do change Y by 4. I want to have if still touching the black, then change Y by 4. So then change Y by 1. So now it's much smoother, as you can see, because it won't go 4 pixels up necessarily. It will just go the highest amount it needs to go up before it's in like a valid position, right? So this is good. We've gotten everything. And everything to text up, down, left, and right. Okay. Anyway, now you might want to go about implementing a bit of gravity, like a jump function, and I'll leave that up for you. If you, I might make a tutorial on it in the future. But as of now, goodbye. This is very awkward.